Welcome students. In this session we are going to see the solution of ordinary differential equations. So, solution of ordinary differential equations. So, we know there are several methods available to solve ordinary differential equations, and in particular we are going to see what are all the numerical techniques available to solve ordinary differential equations. So there are several methods available in this. So the first method is the very important one, including some of the derivative terms. We have Taylor series method. So Taylor series is one of the numerical method to solve ordinary differential equations. So Taylor series method. So in this, Taylor series method, we have the formula yn plus 1 is equal to yn plus h by 1 factorial yn dash, so this is factorial, plus h square by 2 factorial yn double dash plus h cube by 3 factorial yn triple dash, and so on, and where n starts from 0, 1, 2 and so on. So this is the Taylor series method formula. So Taylor series method. So the next method is, so this is number 1, I'll take it as number 1, and the next method is Euler's method. So Euler's is one of the numerical method. So Euler's method, but compared to Taylor's, Euler's is somewhat giving not accurate value, but it is a easy method to solve the problem. So yn plus 1 is equal to yn plus h into f of xn comma yn, where this f of xy is nothing but the given differential term dy by dx. So we have to take dy by dx is equal to f of xy, and again n starts from 0, 1, 2 and so on. So depending on the point what we are calculating, we have to substitute n value. So this is Euler's method formula, and the next one is modified Euler's method. So the extension of Euler's method is modified Euler's method. So modified Euler's method. So we take the formula again, modified Euler's method. The formula is yn plus 1 is equal to yn plus h into f of xn plus h by 2, xn plus h by 2, comma yn plus h by 2 f of xn comma yn, xn comma yn. So we can note the term f of xy is applied in two places. One is inside the bracket the function, and the outer one is also a function. So we have to apply the function very carefully. So first inside the bracket we have to evaluate this f of xy. After that we have to multiply by h by 2, then add with yn. So here one point, here one point. So this point is x and this point is y. Again we have to substitute it in f of xy. And now the next one is, we have Ranji-Kutta method of fourth order. So usually we have first order, second order, third order and fourth order, and if nothing is specified in the question, we follow fourth order Ranjikuta method. So I am checking fourth order Ranjikuta method. So fourth order Ranjikuta, in short we call it as RK method. So fourth order RK method. Okay, so in this method we need to find out 4 k values. So k1 is nothing but h into f of xn comma yn, and k2 is h into f of xn plus h by 2 comma yn plus k1 by 2. So this is k2 formula. Then k3 is h into f of xn plus h by 2 comma yn plus k2 by 2, and k4. So k4 is h into f of xn plus h comma yn plus k3. So we need to find all these 4 k values. So after that we are finding the increment value of y for each and every step. So for one particular point we need to find out k1, k2, k3, k4 and this delta y. So delta y formula is k1 plus 2k2 plus 2k3 plus k4 and this whole term divided by 6. So this will give us delta y. So delta y is nothing but the increment of y value. And after that, to find any point yn plus 1, we need to add this delta y with the previous point yn. So yn plus delta y. So this is the general formula of fourth order Ranjikuta method. Okay, so now we have seen the 4 methods. So all these 4 methods are nothing but single step methods. So to solve single step method, only one initial value is enough. And in multi-step methods, we need at least 4 prior values to solve the problem. So in multi-step method, we are going to see Milne's predictor corrector method. So next, fifth one is Milne's predictor corrector method. So I am writing it as Milne's method. We also call this term as Milne's predictor corrector method. So in this we have 2 formulas. One is associated to predicted value and the another one is associated to corrector value. So first one, yn plus 1 comma p. So this p represents this formula related to predicted value. So this one is yn minus 3 plus 4h by 3 into 2yn minus 2 dash minus yn minus 1 dash plus 2yn dash. So this is predictor formula, and the next one is yn plus 1 comma c. So corrector formula. So this corrector formula is, so just yn plus 1 comma c is yn minus 1 plus h by 3 into yn minus 1 dash plus 4yn dash plus yn plus 1 dash. So these are the methods available to solve ordinary differential equation. So again we recall Taylor series method, Euler's method, modified Euler's method, fourth order Ranjikuta method and Milne's method. Okay, now I am going to explain these methods using any one of the problem. So in this problem I am going to apply one method to find out one particular point, so another method to find out another point, so that I will be covering many methods in a single problem. So now we see the problem. Okay, so problem. Okay, I consider the differential equation dy by dx, or it may be represented by y dash. So dy by dx is equal to 1 minus y along with the initial condition y of 0 equal to 0, and suppose I want to find y of 0.1 by any certain method. For example, find y of 0.1. So find y of 0.1 by Euler's method. So I am applying Euler's method for this. So Euler's method, and y of 0.2 by modified Euler's method. So y of 0.2 by modified Euler's. So modified Euler's method. Then y of 0.3 by RK method. So y of 0.3. So y of 0.3, I am going to use RK method, fourth order RK method, that is Ranjikuta method. So, and at last y of 0.4 by Milne's method. So this is one of the very important problem, because in this method we are covering 4 methods. Okay, so we solve one by one. Okay, so the solution. So let us see the solution. So first, what we are going to use? Euler's method. So in Euler's method we have the formula, okay, yn plus 1 equal to yn plus h into f of xy. So first what we have to know, f of xy. So dy by dx is nothing but f of xy. So dy by dx is nothing but f of xy. So that dy by dx, what is given? 1 minus y. So f of xy is 1 minus y. And y of 0 is equal to 0 is given. So using the initial value and what are all the values we want to find out, and by choosing the interval difference of x value. So this is our choice only. So here for 0, x equal to 0, y is 0, and we want to find y of 0.1, y of 0.2, y of 0.3, y of 0.4. So each and every point having the interval difference. So from one point to another point the interval difference is 0.1. So we may assume h is equal to 0.1. So I am assuming. So I am finding a table of values. So I am constructing a table of values. So first row is x value and second row is y value. So in this we substitute the initial value first of all. So initial value, what is given? 0, 0. So in this is x value. So this is x value, and the right hand side whatever thing is y value. So x value and y value is given. So this is y value. Okay. So for x equal to 0, y equal to 0 is given. Okay. Now I want to find out y of 0.1 by Euler's method. So I am including 0.1 as one of the point. Then I want to find out 0.2 by modified Euler's method. So include this point as a second point. then 0.3, so 0.2, then 0.3, and at last 0.4. We are going to solve it by Milne's method. So all the points I have included in the table, and now we name the points. So this point is x0, x1, x2, x3 and x4. Now correspondingly y we name it as y0, and this is y1, y2, y3 and this is y4. So we want to find all these points. So y1 we want to find out y1, we want to find out y2, we want to find out y3, we want to find out y4. So all these we want to find out. Okay, let us see how to solve it one by one. So first method is Euler's method. So using Euler's method I want to find y of 0.1. So what is y of 0.1? Y of 0.1 is nothing but y1. So now I am going to find out y of 0.1. So first one, to find y of 0.1. Y of 0.1 is nothing but y1. So in this we are using Euler's method. So Euler's method we know the formula. So Euler's method we know the formula yn plus 1 is equal to yn plus h into f of x and yn. So yn plus h into f of xn comma yn. Okay, now what is the point we need? We need to find y1. So we need to find y1. So y1 means we have to substitute n equal to 0. So by substituting n equal to 0, we get y1 is equal to y0 plus h into f of x0 comma y0. F of x0 comma y0. Okay, now we substitute what are all the points available in this. So what are all available? H is available. So what is h value? We can see that the interval difference in x is nothing but, so the interval difference is 0.1. Therefore h is equal to 0.1. So the interval difference in x is 0.1. So or we can say that delta x is 0.1. Okay, now y1 equal to y0. So what is y0? You can see that y0 is 0. So 0 plus h is 0.1 into f of x0 comma y0. x0 is 0 and y0 is also 0. So now this is x value and this is y value, and we know f of xy is nothing but the given differential equation. So that is nothing but 1 minus y. So here I substitute, I take this function. So 0.1 into f of 0 comma 0. So in this I am substituting 0 comma 0. So 1 minus y is 0. So we are getting 0.1. So our y1 value is 0.1. So after finding this, immediately you substitute this 0.1 in the table. So what we have calculated y1? Y1 is 0.1 we have calculated. Okay, so the next one is to find y of 0.2, that is y2. So to find 0.2, that is y2 by modified Euler's method. So now I am finding, so to find y of 0.2, that is nothing but y2 by modified Euler's. So we take modified Euler's formula. So modified Euler's formula, so already we have written. So yn plus 1 is equal to yn plus h into f of xn plus h by 2 f of xn plus h by 2 comma yn plus h by 2 into f of xn comma yn Okay, now what we want to find out? We want to find out y2. So to find y2, what we have to substitute for n? For n is equal to 1. Substituting n equal to 1, directly we get y2. So y2 equal to y1 plus h into f of xn, n equal to 1 I am substituting. So x1 plus h by 2 comma y1 plus h by 2 so y1 plus h by 2 into f of x1 comma y1 f of x1 comma y1. Okay, now we substitute x1 y1. So what is x1? You can look at the table. So x1 is 0.1. So this is x1. x1 is 0.1 and y1 is 0.1. And now we want to find out y2. Okay. So let us take the calculator. For using calculator, we can get the values easily. So calculator is, I am taking the calculator. Okay, so now it's ready. Okay, so x1 is 0.1 and y1 is again 0.1 and h value is also 0.1. So substitute all these. So y1 is 0.1 plus h is again 0.1 into f of xn plus h by 2. So 0.1 plus 0.1 by 2 comma y1 is 0.1 plus h is 0.1 by 2 so y1 is 0.1 by 2 into f of x1 is 0.1 and y1 is also 0.1. So both are 0.1. Okay. So we have to follow the order of operations. So first we have to multiply the terms, then only the addition will take place. So 0.1 plus 0.1 into, so 0.1 into f of, so this is 0.1 plus 0.1 by 2. What is 0.1 by 2? 0.10. 0.10 means 0.05. And then 0.1 plus 0.1 by 2, 0.05. So 0.05 into f of 0.1 comma 0.1. So in this is x value and this is y value, and we know the function 1 minus y. So 1 minus 0.1. So 1 minus 0.1. So 1 by 1 we calculate so that we can avoid the mistakes. So 0.1 plus 0.1 into f of, so what is 0.1 plus 0.05? 0.15. So 0.15 comma, now we should not add these two because this is in multiplication. So first we multiply this, then only we have to add this. So 0.1 plus 0.05 into 1 minus 0.1. 1 minus 0.1 is 0.9. So 0.9. So now I am multiplying 0.05 and 0.9, then I am adding with 0.1. So 0.1 plus 0.1 into f of 0.05, sorry, 0.15, 0.15, comma 0.15, comma 0.1. Okay, we add these terms. So first I am multiplying 0.05 and 0.9. So 0.05 into 0.9, I am getting 0.045, and I am adding this with 0.1. So that 0.145. So we get 0.145. Okay, now we have x value, y value again. So again we have to apply it in the function. So this is x value and this is y value. As we know, f of xy is 1 minus y. We are going to consider only y value. So 0.1 plus 0.1 into 1 minus y. So 1 minus y. Y is 0.145. So now we subtract 0.145 from 1. So 0.1 plus 0.1 into 1 minus 0.145. So 1, I am erasing, 1 minus 0.145. That is 0.855. So this is 0.855. So now 0.1 plus, I am multiplying 0.1 and 0.855. So this into 0.1. So we get 0.0855. So 0.0855. Now we add this with 0.1. So that 0.1855. So 0.1855. So at last we got the y2 value. So this is y2. So y2 is nothing but y of 0.2. Okay. So now we are going to find out y of 0.3. So immediately after finding y2, you substitute it in the table. So 0.1855. So y2 is nothing but 0.1855. So we note this value. So next one we have x3 is 0.3 and y3 we want to find out. So for this we are going to use this x2 value and y2 value. And x2 is 0.2 and y2 is 0.1855. Okay, now let us find. So the next method I am going to use it, Ranjikuta method. So next one is to find y3. We are going to use Ranjikuta method. So in short I am writing RK method. So in RK method we have 4 k values we want to calculate. So let us find out one by one. So k1. So first I find k1. So k1 general formula is h into f of xn yn. H into f of xn comma yn. But what we need? We need y3. So what we have to substitute for n? So f of xn comma yn. Xn comma yn. Now our aim is to find y3. So y3 means put n equal to 0. So I am going to substitute n equal to, so not 0, n equal to Actually first I would like to tell what is yn plus 1 formula. So yn plus 1 is nothing but yn plus delta y. So to get y3 we need to substitute n equal to 2. So I am substituting n equal to 2. Okay, so let us substitute n equal to 2. So h into f of x2 comma y2, x2 comma y2. So x2 we know the point 0.2, x2 is 0.2, so h is 0.1 and f of x2 is 0.2, x2 is 0.2, so x2 is 0.2 comma y2 is 0.1855, right? 0.1855. Okay, so just a minute. So 0.1855. So in this is x value and this is y value. As we know the function f of xy is 1 minus y. I am considering only y value. So 1 minus 0.1855. So now subtract 0.1855 from 1. Okay. So 0.1 into 1 minus 0.1855. So 1 minus 0.1855. So this is 0.8145. So 0.8145. 8145. Okay, so now let us multiply this with 0.1. So into 0.1. So 0.08145. 0.08145. So 0.08145. So let us consider only 4 decimal places. So 0.08145. The fourth decimal is 4 and the next one is 5. So we may add 1 with this 4 or we can leave it. So I am adding 1 with this. So 0.0815. It becomes 15. So up to 4 decimal I have considered. So this is K1 value. So next we find K2. So K2. So K2, what is the formula? H into f of xn plus h by 2. So f of xn plus h by 2 comma yn plus k1 by 2. xn plus h by 2 comma yn plus k1 by 2. So yn plus k1 by 2. Okay. So now we substitute this k1 x and all the values, and before that we substitute n equal to 2. So substituting n equal to 2 we get h into f of x2 comma h by 2, right? So x2 plus h by 2 comma y2, so y2 plus k1 by 2. So we have written the formula for n equal to 2. Okay. So now substitute h value. So h value is 0.1 into f of x2. So f of x2. x2 is 0.2 plus h is 0.1 by 2 and y2. So what is y2? We have calculated 0.1855. So 0.1855. So this is 0.1855 plus k1 by 2. k1 by 2. So what is k1? k1 is 0.0815. 0.0815. 0.0815. So 0.0815 divided by 2. So now 0.1 into f of, so 0.1 by 2 is 0.05. By adding 0.2 we get 0.25. So this is 0.25 comma, so 0.25. Now I am dividing 0.0815 by 2. 0.0815 divided by 2, we get 0.04075 and adding 0.1855, we get 0.22625. So I take only 4 decimal places, therefore it becomes 0.22, so 0.2262. So up to 4 decimal places I am taking, so 0.2262. So now this is x value and this is y value. So now substitute it in the function. So 0.1 into 1 minus y. So 0.1 into 1 minus y. So 1 minus y. So what is y? 0.2262. So 2262. So now I am subtracting 0.2262 from 1. So 0.1 into, so I am substituting, so 1 minus 0.2262, so 0.7738. So we have 0.7738. So 0.7738. Okay, now multiply this with 0.1. So 0.07738. So I consider only 4 decimal places, so that we have 0.0774. So first 4 decimal places I am taking. So this is K3. So next we find K4. So K4 formula. So K4, what is the formula? H into f of xn plus h. So here we don't have a h by 2. So f of xn plus h comma yn plus k3. So yn plus k3. So h into, so h is 0.1 into f of xn. So xn is, okay, I substitute n equal to 2 here. So h into f of x2 plus h. So f of x2 plus h comma y2 plus k3. So now substitute x2. So x2 is 0.2 plus h is 0.1 y2. So what is y2? 0.1855. 0.1855 plus K3. So K3 we have calculated 0.0774. 0.0774. So 0.1 into f of, so I am adding 0.2 and 0.1, so 0.3, so 0.3 comma, so 0.3 comma, now add these two numbers 0.1855, so 0.1855 plus K3 value, K3 is 0.0744. So by adding 0.2599 we have 0.2599. 2599. So this is x value and this is y value. So now 0.1 into 1 minus y. So 1 minus y. So what is y? 0.2599. So 0.1 into 1 minus 0.2599. So 0.7401. So 0.7401. 7401. Point 7401. So we have calculated this. Now I multiply 0.7401 and 0.1. So into 0.1, so that 0.07401. So I consider only 4 decimal places, so that 0.0740. So 0.074. Okay, so we have calculated K1, K2, K3 and K4. So now we find delta y. So delta y, we know the formula, K1 plus 2K2 plus 2K3 plus K4 by 6. So K1 plus 2K2, so 2K2, so K1 plus 2K2 plus 2K3 plus K4, so 2K3 plus K4 and this whole term divided by 6. So divided by 6. So we have calculated K1, K2, K3, K4. So we take all the values. So K1, what is K1? K1 is 0.0815. So K1 0.0815 and K2 is 0.0774. Sorry, K3. So K2 is 0.0815. K2 is 0.0774. Oh, not calculated K3. Sorry, I made a mistake. Okay, let us find out K3. So K3 I am finding. Okay, so K3. So K3, what is the formula K3? So K3 is H into f of